Welcome to the Python Programming tutorial series for Climate Mathematics Theory and Applications. Chapter 9, Python Graphics for Climate Science. In this video, we will review two-dimensional line plots and set up margins and labels. Let's begin. First, we are going to need to import all of these packages in order to compute some of the Python graphics for climate science. Going into section 9.1 in the Climate Mathematics book, we're going to start with two-dimensional line plots and setup of margins and labels. First, we are going to set up our variables, making a time array from 2001 to 2011. Next, we are going to make a temperature mean array and a precip representing precipitation levels. Going into figure 9.1, we're going to set up that figure using the PLT subplots. We are also going to plot the data. We're plotting time against t-mean with a dotted red line. This line will also have a label of t-mean, and then we are going to set the labels for this line. Set the Y label, set the X label, and set the title. We're also going to rotate the Y ticks with a rotation of 90, and we are also going to up the size of both our Y ticks and our X ticks to size 18. Next, we are going to create a twin axis so we can plot two different things on one figure. Then on this twin axis, we are going to plot time with precipitation with a dotted blue line. This line will have the label precipitation, and we are also setting the Y label to precipitation as well. Once again, we're rotating those Y ticks. We do need to create our legend, which you do need to create it for each instance of the plot. So we have a AX, which corresponds to our temperature mean plot, and we're just going to get legend handled labels, and the same thing for the AX1 variable, which represents the precipitation plot. Then we are just going to use the AX legend, and we are going to add the handles together that we just created and add the labels together that we just created, and this legend will be in the upper left corner. Just setting some tick parameters. We want all of our ticks on our plot to be facing into the plot rather than being on the axes. Wrapping that whole entire block with a PLT show, we can run this and we do get a continuous US annual mean temperature and total precipitation plot. We can see by the blue line we have precipitation with time, and on the red line we have our t-mean in degrees Celsius by time. We're going to go into figure 9.2 in the book, and we are going to be modifying this plot quite a bit just to show the Python capabilities for margins, fonts, mathematical symbols, and more. We're first going to set up an X range. We are going to find where Y is positive using NP sign on X. And this 0 just means we are going into the first array from that where function and making those values equal to Y positive. For the Y negative, it's a very similar case. We are aggregating where NP sign of X is going to be less than 0 and grabbing that specific array of values. We're going to set up a figure using that PLT subplots command, and we are also going to define our RC parameters hatch color as blue. Next, for our bar plot, we are using the bar function in this case. We are going to plot X only where Y is positive by the Y value of NP sign with that aggregated X as our input. This will be a red line on our plot. For the next bar command, we are using X, but only where the Y's are negative, and then we are inputting that X array into our sine function. And this will have a color of blue. I'm going to add some text and annotations to our plot. Just a reminder that the first two parameters in the text function are the X by Y coordinate, where you want your string to start. This string will say sine waves in a color of green with a size of 75. We're going to set the X label to angle in radians, theta minus phi naught, and this color will be red. We are going to set the X ticks, set the X limit, set the Y label, the Y ticks to the highlighted text. This AX spines bottom will allow us to set the position of where we want the bottom axes to go. We can also set the bounds on these bottom axes, which we are going to set them to -6 to 6. Next, I'm going to twin the axes we were just working on with the AX1 variable name. And then on this new twin axes, we are going to plot regular X by sine of X. Going through setting the Y ticks on this new axes, setting the Y tick labels, and setting the tick parameters. We're going to add one last piece of text outside of our figure, and it is going to have the string text outside of figure on side 3. These locations that are used are outside of our figure margins, and so this text will appear on the outside. Looking at this beautiful figure we have created, we can see that we have that text truly on the outside of our figure. We have our sine waves in huge font across the middle of our plot, with all of our positive Y values with red bars and negative Y values with blue dots. We can see that we separated our x-axis away from our plot, and it does in fact range from -6 to 6. The left y-axis does range from 1 to 1, whereas our right y-axis ranges from E to A. Moving on to figure 9.3, we are going to illustrate how to adjust the font size, axes labels, and margins. First, we're going to create our data. We're going to name random vals the NumPy random function of the standard normal distribution, and this is going to give us 200 values from that distribution. Next, we're going to create an X using that NP linspace from 0 to 10, and it is also going to have the same size as the randvals variable we created above. Set up our figure using that PLT subplots. We could set our fig subtitle, which is going to be our main title, with a font size of 25 and a Y value of 0.93. This Y value just allows us to have some padding in between our title and our plot. We are going to plot the data using a scatter plot on X with Y values randvals that we created above. Add some plot labels. We're going to set our title. This set title function will input a secondary title under our plot. Its secondary title will be subtitle 200 random values. This Y value of -0.2 places this subtitle under our plot. We're going to set our Y label and make sure those Y ticks are rotated 90 degrees, making them vertical ticks. We could also set our Y ticks equaling to the range in between -2 and 3, and also set our X label to time. Wrapping that entire block in a fig.show, we do get this normal random values plot to pop up. We can see that we have a title, which is our normal random values, but we also have a subtitle, which is going to be below our plot, which is 200 random values. Next, we're going to go into a temperature plot using the NOAA temp data. First, we need to load in this data using the load text function. This is a text file, so you do want to make sure that you set your parameters. We are not going to skip any rows in this text file. Next, we're going to set up the variables that we are going to be using. X is going to be our years, which is that first column of the NOAA temp dataset, and Y will be the second column of that NOAA temp dataset. We are also setting up an array of -99 that is the same size as X, just so then we can place some values into this Z array as we go forward. We are going to make a function that is named for_z, and it will take a Z and a Y. In this function, we are going to go into the for loop, and we are going to take a 5-day average of each temperature from the Y array. First, we are going to make an array of 5 values in that Y array, and then we are going to set our Z equal to the mean of those values. When we return Z, we will have an array of 5-day averages that we will use for our plot. We're going to name this variable ZZ, and we are operating that for_z function on our regular Z array by our Y array. We are going to make an N1 function and an N2 function. These functions will just allow us to see where our Y's are positive and or negative. We're saving the positions of these positive and negative Y's in the N1 variable and N2 variable. We're just going to use these functions with no parameters and save the results as N1 and N2. Next, we go into the actual data creation for our plot. We're going to name X1, which is going to be our X array that only has the N1 values in it. Similarly, we are setting up a Y1 using that Y array with only the N1 values in it. X2 and Y2 will be defined with N2. Lastly, our X3 variable will be the entire array of X and Z. This Y3 variable will be our 5-day averages. Next, getting into our fancy plot of NOAA Global Temperature Time Series, we are going to use the PLT bar function to plot X1 and Y1 with the color of red. We are going to use that bar function again on X2, Y2 with the color of blue. And we are going to use the PLT plot function with X3 and Y3, and this color will be black. Setting our X limits between the years 1877 and 2020. Set our X label to time, set our Y label to temperature degrees C, and set our title. Wrapping that block with a PLT show, we do get this beautiful plot to pop out. And it does depict the NOAA Global Average Annual Mean Temperatures anomalies. We can see that we have blue values for all of our temperatures that are less than zero and red values for everything that is greater than zero. Our black line does show the 5-day averages of the temperature anomalies. Moving on to figure 9.5, we're going to go to the contiguous United States annual mean temperatures and annual total precipitation. Setting up our plot using that PLT subplots one more time, we are going to add additional axes to this plot, and our additional axes are going to be added by getting the x-axis and setting it visible to false. This will allow AX0 to not have an x-axis because we are going to have a overall x-axis for both plots. AX0, we are plotting time versus the t-mean in a red dotted line, and we are also labeling it with A. We're going to set the y ticks for that AX0 plot, set the y tick labels, set the actual y label, and we are going to add some text to this AX0 plot, and you will see that it will say US annual mean temperature in XX large font, and it will be weighted bold. We are also going to add one more piece of text to the temperature plot. We're just going to add an A in the upper left corner to indicate which plot we are talking about. For the second subplot in this figure, we're going to call that second plot an AX1, and we're plotting time versus precipitation with a blue dotted line, and its label will be a B. We're going to add some text to our plot. This text will say the US annual total precipitation with that XX large font, and it will be weighted bold. We're going to set our Y label to precip and rotate those Y ticks 90 degrees. We are also going to add the B letter text to the precipitation plot to make sure we are clear on which one is going with which. This fig.tight layout with the pad equaling -1.5, this ensures that our plots will not overlap, but they will be snug on each other when we show them. Wrapping the whole block of code with a fig.show, we do get figure 9.5 to pop out. We have two plots being shown here with one x-axis but two different y-axes just stacked on each other. We can see that we have our mean temperature up on the A plot and our US annual total precipitation on the B plot. With that, this concludes part 1 of Chapter 9, Python Graphics for Climate Science. Join us next time for Chapter 9, Part 2.